Completing the square is a strange process that we use to help us to factorise some expressions that we can't factorise any other way. And so we're going to start by completing the square on part of a quadratic. So we've only got two of the terms, we don't have a plus c here, and we'll get to the plus c in a minute. So completing the square sounds like you're actually finishing off making a square, which is the idea behind what it is that we're going to do. So let's have a look at the square that we have already. So we've got x squared plus b times x. And what we're going to try and do is we're going to try and make it into a square. So somehow or other we have to combine this yellow area and this green area and turn it into a square. Now if we just moved the green block here, well, that's not going to work. If we just move the green block over across onto the yellow block, it makes a rectangle, not a square. So what I can do, I need to put the same amount on each side. So what I'm going to do is I'm going to take the B block and chop it in half. And half I'm going to press up against one side, and then the other half of it I'm going to put at the bottom. Now if I move those two green slices up against the yellow slice, what I'll have is something that is almost a square. And what it needs to complete the square is this little piece here. Because if I pick up this little piece and I move it, it completes that square. It makes it into a perfect square, perfectly square. So you can see that the side length of the yellow box is x. The side length of these shorter rectangles, because remember I chopped it in half, so it was b wide, now it's b divided by 2 wide. And this side is also x plus b divided by 2. So that means that this side here is b divided by 2 and this side here is b divided by 2. So that little square has an area of b divided by 2 all squared, because that side length is b divided by 2 and that side length is b divided by 2, and the area of the square is length times width. So what we have is, to complete the square, we need to add b over 2 all squared. And that's what we need to complete the square. The side length of the square that we get when we complete that, when we put that little square back in its box, over there, move over there, is x plus b divided by 2. So that's our side length there. And I've got it in brackets because the next thing I want to show you is that we can actually write the area of the square. When it's completed, the square has an area of x plus b on 2 squared. And this is the bit that we want to get to and use later. But for now, let's practice completing the square on some quadratics that have some numbers with them. Okay, so here are some parts of quadratics that needs to be finished off. So the question is, what do we need to complete the square for these? Okay, so we've got x squared plus 8x, and we need to complete the square here. So in this one here, our b is 8. And so what that means in terms of our completing the square thing is that this distance here is 8. So when we complete the square, we're going to halve that 8. Remember we halved this and put half of it down the bottom. So we're going to halve the 8. And what that's going to mean is that that little square at the bottom is going to be half of our 8. So 8 on 2. And that square is worth 8 on 2 squared. That's what we need to add to complete the square for the first one. Let's have a look at the second one. In the second one, our b is 12. So using the same idea, to complete the square, we need to add in this little blue bit, and the little blue bit is b on 2 squared. So what we need to add here is our b is 12, and we need to add in 12 on 2 squared. Now both of these that I've put here can be simplified, so we can write this as 8 over 2 is 4. So we could write that as 4 squared. We could also write it as 16. The 12 over 2 we can write as 6. So that would be 6 squared. Or we could write it as 36. Any of those is correct. So what about this next one, where we've got plus 3? Well, we still use the same process. So we need to divide that 3 by 2. So we need to divide the 3 by 2, and then the area of the square that we need to add in is 3 over 2 squared. Normally you would just leave it like that, you wouldn't expand it out. So let's have a look at some of the ones on the other side. X squared minus 10x, and you'll see that I've got the minus in a green. The reason that I've got the minus in green is that the minus is part of our b. So our b for this one is in fact minus 10. So what we need to add in is b minus 10, divide by 2, and square it. So this one we can write 10 divided by 2 is 5. So this one we can write as minus 5 because it's minus 10 divided by 2, minus 5 squared. And if you wanted to work that out, it's minus 5 times minus 5, which is 25. So we need 25 there. So I'd like you to have a go. These are a little bit difficult here because they're odd numbers. We have to divide by 2, but I want you to have a go. Pause the video and then I'll put the answers up. Okay, so the first one is our b value, which is minus 5 divided by 2 squared. And our second one is minus 7 divided by 2 all squared. Hopefully you're starting to get the hang of these now. If there's some more for you to practice on, now's a good time to practice. So let's have a look at the next little bit in the challenge of completing the square to factorise. So the next step is using the idea of completing the square to allow us to factorise using difference of perfect squares. So the first step in doing this is to think about how we go about completing the square when we've got 3 terms. So we've got our trinomial. So what we do is we still think about them as areas, and you can see here that I've got the C as a block that is 1 block wide and C blocks long. And again, we're going to try and make a square, but we're going to make the square with just these first 2. We're just going to leave this little bit over here for the minute. And so we use the same process, divide the B section in half, plug them together to make a little hole. See, the C is still just hanging here on the end. And this gives us this situation down here. That way. Okay, so what we've got here is this is our original thing from before to complete the square. And that allows us to write that section there as a square, as a perfect square, if you like. And so what I can do is I can take this little bit here and write the area for that square as the side length, so x plus b on 2 squared. So the area of that square, the area of this square, when we put that in there, is length x plus b on 2 times width x plus b on 2. So x plus b on 2 times x plus b on 2 is x plus b on 2 squared. But we originally started off with just this thing here. And if we add a little blue square into our equation, then we've actually changed what it's worth, because it was originally worth just the yellow, the green, and the red. So just the yellow, the two green bits, and the red bit. So if we're going to complete the square by adding in this blue bit, to keep the total amount of stuff the same, we kind of take away, so this is like a little invisible taking away square, and we take away the same size square. So we've got minus b on 2 all squared plus c. So what that leaves us with is that for our original equation that we had up here, x squared plus bx plus c, so x squared plus bx plus c is the same as x squared plus bx plus the little blue square we added in, take away the little blue square we added in, so we haven't actually changed the amount that we've got, plus the c on the end. So this is what we call completing the square for that particular function. But the other way that we can do it, and this is the more useful way, is that we can write it as a square, as a perfect square. So instead of writing this bit as the sum of all of those areas, which is what it is here, I can write the area as the side length squared. And so this pink section here I replace with this little bit down the bottom. And the other bit that I have left over, which is this bit, still remains the same. And I just leave that on the end just for the minute. So we're going to practice writing quadratic equations that are in this form, where there's a value for b and a value for c, into this pattern here. So you'll notice that in the brackets we've got b on 2 here and we've got b on 2 here. This one's the squared version. So we'll start working with this by completing the square. We need to add it in and take it out so that we're still just left with the x squared plus bx plus c value. And then we're going to tuck this little section in and come up with this, and tidy this section up to come up with this. Let's have a go at some. Okay, so the normal instruction for the question will say factorize the following by completing the square. So the only time I suggest that you ever complete the square is if you're told to complete the square. Otherwise, try everything else that you can to avoid it. But anyway, here we go. So the first thing we need to do is to identify our b, and this is our b here. So our b is our coefficient of our x term. So our b is equal to 4, and so our equation becomes x squared plus 4x. Now we're going to add in our b on 2, oops, not b, our b is 4. So we're going to add in 4 on 2 squared. We're going to take away 4 on 2 squared. And then we're going to remember that we've got that plus 2 on the end. And then what we're going to do is we're going to combine this perfect square section into the perfect square that it was. And then we're going to have left over on the end the minus 4 on 2 which is in fact 2 squared. I'll leave it as 4 on 2 for the minute. Squared plus 2. Okay, so if our side length has an x in it, as it will if we think about our square that we made, so that's our x. Oops. And this little section here is b on 2. So our side length is x plus b on 2, and our b is 4 on 2. So this simplifies down to give us x plus 2 squared minus 4 divided by 2 is 2, minus 2 squared plus 2. And now we're just going to tidy up the little bit on the end. X plus 2 squared minus 4 plus 2. So x plus 2 squared minus 2. Now you'll notice at the top that I said we're going to complete the square, and then we're going to use difference of perfect squares to factorize. So now we've got something squared minus something else. To use difference of perfect squares, you need to have a squared minus b squared. So our second thing needs to be squared. So we've got our first thing, which is this whole bracket squared. That's our first thing. And we need our second thing to be something squared. And so what we're going to do is we're going to write the 2 as the square root of 2 squared. So now we can use our difference of 2 squares pattern, or difference of perfect squares pattern, DOPS, our difference of perfect squares pattern, and we can write our equation that we've got here as fully factorized terms. So our first bracket is going to have a, our first bracket has a plus b, so our a is x plus 2 and our b is root 2. So our first bracket looks like this. Now we're going to do the same with a minus sign in between, a minus b. And there we have our quadratic factorized. So let's have a look at what we did. So the very first thing that we did was that we completed the square. And completing the square was this bit here. There's our square completed. In fact, the top line, that's our completed square. Then we tidied up here, and then finally we used our difference of perfect squares for this section down here. So it's a long process. You have to make sure that you keep track of where you're up to. So let's have a go at one more. So let's have a look at this one. So we've got x squared plus 6x. So let's complete the square on that. So we've got x squared plus 6x, and to complete the square we need to add in b over 2. So our b is 6, and so we're going to add in 6 over 2, and we're going to take out 6 over 2. And don't forget we have our plus 3 on the end. And then what we're going to do is we are going to combine those first 3 terms together that are our perfect square. These ones here come together. And so we're going to write it as its side length. And our side length is going to be our x plus our 6 on 2. And that is all squared. So that bit here all combines down into this shortened version, and we still have this bit left on the end. So let's just add that in. So minus 6 on 2 is 3. So we've got minus 3 squared and plus our 3. And that's our square completed. So we're just going to tidy up the end bit now. So we'll tidy that up by writing the 6 on 2 as a 3 and the 3 squared as a 9. And then we can do 9 plus 3 to give us x plus 3 all squared minus 6. Square completed. So this is completed the square form. So now we've completed the square. So now we're going to factorize that using difference of 2 squares. So I have to write it as something squared, take away something else squared. So the thing that's going to go in my second bracket is going to be the square root of 6. And then we need to use our difference of squared patterns, recognizing that this is our A and this is our B. So let's now put those into our two brackets, one with a plus and one with a minus. And I'm kind of putting them to the back because we've got x plus 3 here at the front, and it takes up a little bit more room than the square root of 6 that goes at the back. And that's how we complete the square, and we use difference of 2 squares to get it into factorized form. And so finally, I want to show you how to complete the square, how to complete this square to get to here in the quickest way possible. And what it involves is kind of skipping out this step here. Okay, so I simplified this 6 over 2 and turned it into a 3 here, but I'm going to turn it back because I want to show you that if we're going to skip this line here and come straight to here, we can do it by recognizing that our B was worth 6, and so in our pattern here, this is 6 on 2, this is our B on 2 that goes in here, and then on the outside we add minus B on 2 squared, and then we tidy this up and we tidy this up. So we can use this kind of shortcut with other quadratics. Let's have a go at one now. So here's one I prepared earlier, and this is the pattern that we're going to put our completed the square version into. So it matches exactly on this line here. So we're going to have our x plus our b on 2 squared go in here, and then we're going to have minus b on 2 squared here plus 3. So in this case, our b here is 12. So what we do, oops, I forgot to fill in the x here. What we do is we add in our 12 on 2 and we take away that same 12 on 2 squared. So if we set up the pattern, we just pop the same number, which is b on 2, into both of those squares. And it saves us doing this step here, because now we can just tidy that up and we'll get x plus 6 squared minus 6 squared plus 3, and we've saved ourselves a line. And you can even save yourself another line if instead of writing 12 over 2 here, you just write that straight as a 6 and that straight as a 6. So we could continue this on and factorize it, but I'd really like us to have another go at putting a quadratic straight into this pattern here. So have a go at this one. So press pause and have a go, and then I'll do it for you. So how did you go? Half of b, so half of minus 10 is minus 5. So minus 5 goes in that bit there and that bit there. So minus 5 squared is 25. So we've got minus 25. Gives us a 17, which when we write it as a square, we use our difference of perfect squares up here. We've got x minus 5, and our other number that's squared is the square root of 17. Now it's time for you to practice some on your own. Good luck.